Hey guys, I'm here today to talk to you about a couple of different things that have come up. People have been wanting to know some answers to some questions regarding materials, which is really cool. It's the first time that I've gotten this inundated with people curious about the science behind chassis bracing. And it's something that I really would like to talk more in depth about. And sometimes it's a little bit difficult on Facebook to go through a giant novel of the things I've learned in the last 7 years of doing business. So I'm going to go over them right now, a little bit at a time. So first up is cups. The cup is the mounting point for the brace. So I have a traction bar right here. These are what I call the cups. I'm sure every other company has its own names, but I've been calling them cups since I started. The cup is the area where the brace transfers its load. It's actually a really interesting segment of design on this, and it's commonly overlooked, which I'll get into in a minute. But basically, my cups are done with 120 wall tube steel. It's 1.5 inch in diameter. Somewhere a competitor, I'm sure, is jotting notes really quickly. But anyway, each of these is hand TIG welded. So I actually take this torch right here, and you can kind of see right there, I go through and I lay a bead all the way around it. I use an autogeneous method, which means that I actually am pulling from one to the other. So there's no filler rod. What this does is it keeps the material a uniform alloy of steel. I could weld it with stainless with a filler rod or any other type of ERW. And what would happen is there would be a differential in the type of material, which could lead to fractures or early failure points. Whereas this, it stays a consistent mild steel throughout the whole thing, making it much stronger. Anyway, I also use 120 wall. This is an interesting thing because most of my competitors use a lighter wall. This right here is about 0.65, plus a little bit thicker for powder coat, but it's an 0.60, 0.65 wall thickness. Now, I used to use the same wall thickness a couple years ago when I was first starting out, and it was cheap, and that was my big thing. Was I was trying to make a cheap product. I wasn't thinking too clearly, and I didn't understand what was going on. And I think most companies are in that same standpoint of they're trying to produce a cheap product, and they maybe don't necessarily have the understanding of what goes into the forces. And so the 0.60 makes a cheap cup. However, it causes actual cup deflection. So as this brace is loaded up, and the pressure is distributed into this cup, it actually starts to bend the cups. And I started noticing that on a couple of customers who really pushed their cars. There was actually deformation inside the cup, and so you were getting an oval shape. And it really intrigued me, and I decided I was going to go about to solve it. And the way I came about was using 120 wall. This is basically the same stuff you use on a roll cage. Same wall thickness, same material size. Some people will argue 1 3/4. Yeah, if you have a heavier car, 1 3/4. But moral of the story is this is basically roll cage material, so it's extremely strong. Now, between the two, this causes a completely flat mating surface. My competitors tend to go with a MIG process along the outside. It makes it quicker. I used to do MIG just the same. It was a much faster process to get the cup welded up. It's also cheaper. You don't have to run, the expensive argon. You just run a steel mix gas to back purge it, or to use as a gas shield. So I decided to go with the TIG welding because that allows this to sit perfectly flush. Whereas if you have the MIG welds, some of my competitors do it, and it causes this to kind of have a rocking effect. Now, what that's doing is it's not allowing the perfect transfer of the load. There will be some deformation of the washer on the bottom to suck it in, but it isn't an ideal situation. And so I spent a little extra time. It cost me a little extra money, but I like to make sure that my cups are the best on the market because that's the groundwork. Anything after that, it has to have a reliable foundation. And so I spend my time making sure that the cups are the best that they possibly can be.